All right, next we have question 7, which says find the average distance between points in the disk D and the origin. And D here is the set of all points r theta, where r ranges from 0 to 4. So in other words, it's just the disk centered at the origin of radius 4. Okay, so if I take a point in the disk, let's say this point right here, and I label its coordinates x, y, then I can measure the distance from that point to the origin as, and I'll call that distance d. So d of xy is just the square root of x squared plus y squared, using either the distance formula or equivalently the Pythagorean theorem. Okay, so what I'm saying now is to find the average distance. I'm saying, okay, as we range through all points in the disk, right, what is this average distance that we're going to observe between these points and the origin? Okay, and so in other words, what we want to compute is the average distance d bar, which is going to equal 1 over the area of our disk, capital D, times the double integral of our distance function, and we're integrating here over the disk. Okay, so let's see now. I'm integrating over a disk, and my distance function involves x squared plus y squared, so that suggests using polar coordinates. And in fact, in polar coordinates, right, the distance between our point and the origin is in fact just r, right? You can see that here by just saying x squared plus y squared is r squared, and we're taking the root of that. But you can also just see it from this very definition of what r is, right? Remember, r is just the radial distance between the origin and our point, right? So we're integrating r, and our bounds of integration would be 0 to 2 pi and 0 to 4. So we're going to have r, and then, careful there, dA is r dr d theta. So that's this portion. And then the area of the disk is going to be pi times 4 squared, so that'd be 16 pi. Okay, so we're looking at that. And a couple things. Notice the integral does not depend on, or the integrand rather, r squared does not depend on theta. So this thing can come out front, and then we're going to multiply that integral by the integral from 0 to 2 pi d theta, and that's just, well, 2 pi. So in fact, I'm going to get 1 over 16 pi times 2 pi, that's coming from the theta integral, times the integral from 0 to 4 of r squared. Okay, so this is going to give us an eighth, and then we're multiplying that by this r cubed over 3 from 0 to 4. And so I'm going to get what? 4 cubed, that's 64 thirds, and plugging 0 in will give us 0. So 8 thirds is that average distance we're observing here, right? So as I let all these points range over the disk, the average distance from those points to the origin is 8 thirds. All right, that does it.